Hi, and welcome to the virtual analog chapter of the Alchemy tutorial video. Subtractive synthesis is the basis of virtual analog sound design. This involves starting with a waveform rich in harmonic overtones, and then shaping those harmonics with filters to form the final sound. There is a very good reason why the sawtooth wave is the most commonly used of the basic waveforms, and why we see it here in our cleared preset. The sawtooth wave contains all the harmonics of the fundamental, both odd and even, and all the way up to the upper limits of the system, which in the case of a digital virtual analog synth will be half of the sampling rate. A sine wave, by contrast, consists of just a pure fundamental frequency, with no extra harmonics above it. So filtering will have little effect other than to cut or boost the level of that single first harmonic. The square wave contains only odd harmonics, which gives it a characteristically hollow sound. But like the sawtooth wave, they extend all the way up to the Nyquist limit and provide a good starting point for further shaping with filters. If I adjust the symmetry knob, I can create pulse waves instead. These reintroduce the even harmonics again, but we now have patterns of missing harmonics that vary depending on the pulse width. Pulse width modulation is the basis of many classic analog type sounds, and square and pulse waves are the next most common basic waveforms for subtractive synthesis. Another very common technique to add movement to a sound is to combine multiple detuned oscillators. If I turn up the number of oscillators knob to 8, we can hear that we now have 8 copies of the waveform, all at slightly different frequencies, and so shifting in and out of phase with each other. I'm going to turn the gain down a bit to compensate for the increased level. Notice that the pitch variation knob is turned fully up. The name refers to its function when in additive mode. In VA mode, however, it controls the starting phase of the wave. If I turn this knob down, we can hear that every note I play starts exactly the same, with identical phase sweeps between the detuned oscillators. This can be very useful when creating punchy bass or drum sounds. But if I turn the knob back up to 100%, the initial phase will be randomized for each note to emulate the free-running oscillators in analog synths. I can show this more clearly if I turn source A off temporarily, enable source B instead, and set the starting phase to 0. If I now do the same for source C, the basic sawtooth wave just gets louder. But if I change the starting phase for source C, we start to get partial phase cancellation between the two sources, and the tone changes. If I set the phase to 50%, the note goes up an octave because the first harmonic cancels completely. And if I set it to exactly 100%, the starting phase is randomized, so every note ends up sounding slightly different. Let's turn these sources off again and return to our detuned source A. The pitch knob controls the amount of detuning when set to unison mode, which is the most common choice for virtual analog synthesis. The other options here can also be useful, however. If I switch to harmonic, the pitch knob has a much more dramatic effect, and double-clicking to set it halfway up will stack all 8 waves up at harmonic intervals. I can also get useful results by setting the pitch knob to 25% to make the first interval a fifth instead of an octave, or by switching to double odd, which stacks waves in pairs with subtle detuning. If I switch the amp knob to fundamental mode, I can use it to control the balance between the first oscillator tuned to the fundamental and the extra oscillators tuned above it. If I switch the source to stereo mode, I can use the pan knob to spread the waves from left to right and create an artificial stereo effect. Switching the mode to odd-even instead of unison creates a more pronounced version, as alternate oscillators are hard-panned. Notice that our source has a filter tab over to the right, which reveals 3 filter slots. These are slightly simpler than the main filters, with just cutoff and resonance and no drive controls, and they have a shorter list of filter types to choose from, with only 2-pole filters available. But we still have the distortion options, So I could load a distortion effect for slot 1 to add some extra rich harmonics, and then enable slot 2 for some actual filtering. If I also turn on filter 3 and set it to the same frequency, I can create a 4-pole version of the filter. Or alternatively, I could load another distortion stage instead. These filters can be modulated just like all the other knobs in the upper section. So each source can be thought of as a powerful virtual analog synth in its own right, without even using the main filter sections at all. Here's another example. I've started with a cleared preset again, and this time I'm going to select a basic triangle wave. This is similar to the square wave as it has only odd harmonics, but the level of these harmonics drops away much quicker than for a square wave, so the triangle doesn't sound as bright. I'm going to select a 4-pole Moog type low pass for filter 1. And I'm also going to modulate the filter cutoff with note property key follow. If I leave the modulation depth knob at 100%, the filter cutoff will track the pitch of each note I play, and double-clicking the cutoff knob to set it halfway up will tune it to precisely 1 octave higher than the fundamental, or in other words, the second harmonic. Now we see the level of the first harmonic is unchanged, but the third harmonic is quieter than it was, the fifth harmonic is hardly present, and everything above that has been effectively removed completely. If I turn up the resonance, nothing much happens because the second harmonic to which it is tuned is not present in the triangle wave. I'm going to disable the filter temporarily and return to the source again. If I switch to the spectral section, we see that it's defaulted to white noise, and if I turn it on, we get a simple random noise generator. If I switch the filter back on, we lose the high frequencies of the noise as well as the upper harmonics of the triangle wave, as you would expect. But now, if I turn up the resonance, the filter starts to oscillate at the cutoff frequency and fills in the second harmonic that is missing from the triangle wave. If I also turn up the number of oscillators slightly in the additive section and increase the release time for the main amp envelope, we have the basis of a breathy pad type of sound. Another cleared preset now for another example. This time I want to make a bell type of sound, so the first thing I will do is adjust the amp envelope accordingly. I'll turn the sustain down all the way and set both the decay and release the same, so I get the same long decay regardless of how long I hold down the key. Bells tend to have lots of bright overtones, but these are usually inharmonic partials, so the regularly spaced harmonic partials of a sawtooth wave are not really suitable. So let's pick a sine wave instead, switch to the filter section, and drop a ring modulator into slot 1. This multiplies the source signal with another sine wave, which creates sum and difference sidebands. So if I tune the cutoff knob around the mid frequencies, I can start to introduce a clangorous metallic character to the sound. Turning up the resonance knob offsets the modulating wave to create amplitude modulation instead of ring modulation, which allows the original sine wave through as well as the sidebands. I'm going to modulate the cutoff knob with key follow, so that the modulating wave tracks the notes I play, and we maintain a fixed frequency ratio between the two sine waves as I play up and down the keyboard. I'm also going to set up filter 2 with some more amplitude modulation, but I'm going to switch the filters to run in parallel instead of in series. I'll set the cutoff higher than filter 1 to add a high tinkly element, and copy the key follow modulation from filter 1. But this time I'm going to turn the key follow depth knob down just a bit, so that the modulating wave doesn't quite track the keyboard fully, and each note ends up with a slightly different set of partials. Now I'll load up a 4-pole low-pass filter in the main filter section. I'm going to modulate the cutoff knob with key follow once again, but this time tune the cutoff approximately to the fundamental frequency of the note by setting it to about 260 Hz. I'm also going to modulate cutoff with an envelope. I could create a new envelope for this, but instead I'm actually going to reuse the main amp envelope with a depth of about 60%. But to make it close down quicker at the start of the note, I will assign it a mod map and shape the modulation by pulling the centre node down to make a curve. That's all I have time for in this video. Thanks for watching.